Alrighty, so today we are going to do our Unit 2, Topic B Quiz Study Guide. We already took Quiz A last week. Our quiz is tomorrow for Quiz B. So, your quiz is only 5 questions. 1, 2. 2 of the questions are multiple choice. So 2 out of the 5 questions, you could do your best guess. So always remember that, multiple choice, get rid of the junk, what do they say? What's the phrase?
So we're most likely
Slash the trash.
So we're most likely to get it through.
You have, yeah. If you don't even know what you're doing, you have a best case scenario of getting those 2 correct because you guessed correctly. Now, obviously, we can do better than that though. Alright, so let's look at number 1 on our study guide. This is going to look exactly like the first question on your quiz, only I changed the numbers, okay? You can see my handwriting there. The 2 triangles are similar. Find the side lengths of A and B. Note that the triangles are not drawn to scale. So obviously this is not 2 inches and then this is 4. Look at how big that is compared to that. They're not drawn to scale, but you just have to trust that the numbers are correct. So remember, what does the term congruent mean?
The same.
Congruent equals exactly the same. Whereas similar equals, what do I have to do to my 2 triangles if they're similar to get them to be congruent?
Divide. No.
Multiply or divide, yeah. We're going to do our scale factor. So similar means can be congruent.
I can give you the same shape, but it's smaller.
Mhm.
The original shape.
If dilated. So, they are telling us that these 2 shapes are similar. So that means that we know we can use a scale factor to dilate one to get to the other. The first thing that we need to do is find the like-minded sides. So from the jump, we can see that this angle right here, probably it gets rotated upwards, so this angle matches right here. If that is the case, we know that the bottom 4 right here, I'm going to color code it for you guys, this line right here, its corresponding side is the 8 right here. If that's the case, then we can guarantee that our long side right here corresponds to which side, B or 36?
36.
36, right. It corresponds with our long side here. And that leaves us 2, which corresponds with B.
A.
B. Yes, you're fine. So now that we found our corresponding sides, it's time for us to figure out how to dilate them so that we can find our B and find our A. So I'm going to start by writing all of the small triangle information here. So I'm going to start with the smallest side, which is 2, and then I'm going to write 4, and then my missing side is A. I wrote down all my small triangle information. Now I know that I have to do a scale factor. So this is the information for my scale factor. So times my scale factor, but I don't know what my scale factor is yet. All right? And then lastly, we know that it equals our big triangle. So I'm going to write the information for my corresponding sides. So 2, purple, corresponds with B. So my big triangle is B right here. 4 is in red, and that corresponds with my 8 over here. So I'm going to write 8. And then my A right here is my blue. It corresponds with the long side here. That's 36. So now all we have to do is find our scale factor so that we can find our A and our B. The only one out of all 3 of these options that gives us both numbers is this middle one. What times 4 equals 8?
2.
2. So if I times, let's use a different color for our scale factor. Let's use pink. If I times 4 times 2, I get 8. So we're assuming that our scale factor is 2. So with that in mind, 2 times 2 is what? 4. So that means we found B. B is 4. What do we have to do to 36 to find A though? So 36 is our answer. So we're timesing by our A times 2 equals 36. What do we have to do to 36 to find our A? Divide by 2. So we're going the other direction. We're dividing by 2. So it's still times going this way, but going this way, we have to find our A. We're dividing by 2. What's 36 divided by 2?
13.
Let's check it on our calculator. You'll be allowed to have a calculator on this. What'd you say?
18.
18 is correct. So yes, 36 divided by 2. If you need to double check it on your calculator, it is 18. So what is our A? 18. All right. That is how you find your missing sides. Step 1. Your missing sides. Step 1. Find corresponding lines. Step 2. Figure out scale factor.
Ms.Kreger,
Mm-hmm.
why don't we follow small groups there?
So find corresponding lines, figure out scale factor, and then 3, solve for variables. Sorry, I had a little typo up there. So yes, overall, we have 2 triangles, that we have some missing sides. We need to figure out what they are. We write out our smalls. We need to find our scale factor that equals our big. We figured out that 2 times 2 equals 4, so that's our B. We know that our 4 and our 8 are connected, so it's 4 times 2 equals 8. And lastly, A times 2 equals 36, which ultimately becomes 18. Next, step 1, find corresponding lines. That was our color code. Step 2, figure out our scale factor. Step 3, solve for our missing variables. Do we follow?
Yes, ma'am.
Alrighty, cool. Cool. Alrighty, I'm gonna slide down. Number 2. Here, there is a pair of triangles below. 1 and 2. Is triangle ABC congruent to triangle DEF? Explain your reasoning.
Probably not.
Are these 2 congruent? Are they exactly the same?
Oh, no. Yeah, they are.
No.
These are exactly the same?
Oh, no, they're similar. But they're not.
Very good. No, these are not congruent because they are not.
They're similar because if you were dilation by 3 or 2, it will be the same as us. Dilate by 2.
Very good. These are not congruent because they are not exactly the same size. They are not congruent because they are not exactly the same size. However, is triangle ABC similar to triangle DEF? Yes. We can check that by seeing 1, 2, 3, 4. So this is 4 units. 1, 2, 3, 4. This is 4 units. And we check it over here. 1, 2. This is 2 units. 1, 2. This is 2 units. What times 4? What times 4 equals 2?
4, 2. Wait, what?
Times 1/2. If you times it by 1/2, you get 2.
Oh,
Remember, when you're making it smaller, it is a fraction. So you would say,
how would you do that? Times you just times 4.
And you literally write it out as 4 times 1/2.
No, I'm saying, like, how would you solve it? How would you do
What is 1/2 of 4?
it? What?
What is 1/2 of 4? 2.
Oh, 2.
There you go. Yes, because these two are similar because I can dilate them by a scale factor of 1/2. You need to be able to explain why. You can't just say, yes, I will not give, that will be a 0. That will not even be like half a point. If you say, yes, they're similar, why? Why are they similar? How do you know that? So you would have to say, no, they're not congruent because they're not exactly the same. Yes, they are congruent because they are exactly the same. Yes, they're similar. I can dilate them by this scale factor.
What's the scale factor?
For this,
Yeah.
1/2. Because we're going big to small fraction. Look, big to small equals fraction. Small to big equals whole number.
Sergio. Stop it. Yeah.
Big to small fraction. Small to big whole number. Remember,
What?
Okay.
alrighty.
Oh,
No? Okay, wait. I'm gonna slide it up for people that are having trouble seeing that well.
Or maybe they could like get up and like.
Out of curiosity, if I like recorded this the night before and then I just put the video on the board, would you still pay attention and do the study guide together as a class?
Yeah.
Because I might do that if I can like get. I want to buy a fancy microphone and everything.
How much?
Full. Well, it was on sale. It was $200, but then it was like 50% off because it was like Prime Day deals. What's 50% of $200?
100.
Yeah. See, I can still do math.
Oh, really, Papa?
All right, I'm flipping it over.
All this stuff.
All right, this is the second version of that question that we just did. What? Oh, that, yeah, I know. Alrighty. So this is just the exact same question we just did, just in a different, diagram. So, is triangle BCD, so BCD,
It's not
congruent
congruent.
to triangle BCD prime? Why, Elijah?
It's not congruent because first they dilated it like negative, and they also moved it. Like the side lengths are different.
Yeah, the side lengths are different. Not congruent because they're not the same size.
What page is it?
And
Is on the back page of our first.
for question B, it's similar. If you were to dilate it up like positive, then you were to rotate it.
Yeah. So, yeah, they're not congruent because this is very clearly smaller than our prime image. However, yes, Elijah's right. They are similar. And we can check this by looking. Okay, so this is our center point. We count 1, 2. So our D is at 2 right here. And then we look at C, center point. 1, 2. So our C is at 2. Let's count our B. So we start at center point.
Why is there two like
What?
slashes like next What's in the letters? Is it
Because it's a circle. Oh, that's just how they labeled prime that time. It's nothing special, yeah. All right, so now let's check B. So it's 1, 2, 3, 4, 5. All right, let's see if this is a scale factor of it. So we go 1, 2, 3, 4. Check our C. 1, 2, 3, 4. And then let's lastly check our B, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
What's so funny?
Is this a scale factor? What times 2 gets 4?
2.
What times 2 gets 4?
2.
What times 5 gets 10?
2.
2. So our shape is similar because we can dilate by a scale factor of what? 2, yeah. Because remember, bigger to smaller equals fraction. Smaller to bigger equals whole number.
How did you get 10?
I counted. So look at where your B's at. We start at our center point.
Oh.
We go to this point. 1, 2,
I thought
3,
you started from D.
4.
I was confused.
5, 6, 7, 8, 9, 10. Yeah, the circle grid can often be a little overwhelming if you're not aware. Like, you gotta always make sure that you're starting your count from the center point, from the origin every time.
Or in a straight line.
Yes, yes. Okie dokie. Oof. Let's look at number 3. I'm going to slide up a little slowly so that y'all can still see the writing. Or at least that last one. Polygon MLK is rotated 180 degrees clockwise and then dilated by a factor of 2 centered at the origin, so the center of the shape. The resulting image is polygon MLK prime. Which statement about the 2 polygons is true? The easiest way, so this is a multiple choice question. The easiest way you can check this is, let's just kind of draft it out. So we're going to write our little example down here. I'm going to draw polygon MLK, so MLK. Martin Luther King Jr., yeah. I mean, I did it because they're my initials too, but yeah, we can do it. It's MLK, Martin Luther King. Okay, now, milk. I did go by that in high school, actually, yeah. So, this is my original shape, my image, my pre-image. Now we need to make the prime image. The first thing it says that happens is it rotates 180 degrees clockwise. So I'm going to rotate it 180 degrees clockwise. So M, and then K, and then M. So we flipped it over. That is a 180 degrees clockwise rotation. Because remember, it's a straight line. 180 degrees has to be a straight line. So that's 1. We went clockwise, right? Rotated clockwise. That's the first step that they told us to do. And then the second is they dilated by a factor of 2. So now we have to times it by 2. And again, you're just eyeballing this. But I'm going to make my bigger shape. Whoa, I went a little overboard. That's way bigger than 2, but that's okay. I'm going to do here. L, K, M. So I dilated it by a factor of 2. I'm using air bunnies because it's a little bit bigger than 2, but that's okay. The resulting image is MLK prime. So I make sure I have my primes right. This is just me showing my work so I know how I did it. What statement is true about the 2 polygons? So 1, the corresponding sides of MLK and MLK prime are congruent. Are these 2 shapes congruent? No. So we can cross out A. The corresponding angles of MLK and MLK prime are congruent.
No.
What did we say yesterday about angles? Angles never change.
Oh, yeah.
So would this angle right here be congruent with this angle right here?
Yeah.
Yes. It's a B.
Oh, that's
Angles never change if they are similar. Angles never change if they are similar. Now we can double check. The perimeter of MLK here is 1/2 times the perimeter of MLK prime. Is this right here, the perimeter here, is 1/2 times the perimeter of MLK prime? No, because it would have to be flipped. It would have to be the other way around. We'd say for this to be true. You would need it to be times the scale factor. Because remember, your perimeter, remember when we did that worksheet the other day? The perimeter always has to match the scale factor, which is 2 in this instance. Our scale factor is 2 from the question. And then area, the area of this one is 2 times the area of this one. No, because this is so much smaller. The area of this shape could not possibly be 2 times the area of this one. So we know that these two are wrong. The corresponding angles of MLK and MLK prime, they have to match. Angles never change if they're similar. And we know that these are similar because we did a series of transformations to get there. We rotated it and then we dilated it. They get to the same location every time. Okie dokie. We have 2 more questions left. Let's flip it over to number 4. I'll put it back on the board in a second. So anything you miss, I'll put it back up.
Oh, really?
Let's do green. All right, another multiple choice. Let's look. Let's take a gander. I gotta zoom out a bit for this one so you can see all the. Okay. Ooh. You know what? That's all right.
Exactly.
Which series of transformation maps WXYZ to WXYZ prime? The very first one, let's just go through the motions and see what happens. Dilate XYZ by a factor of 2 about the origin and then reflect it. So let's dilate this one by 2. So first, the origin is 0, 0. So dead center. I'm going to draw my rays so that I can kind of see what they're looking at. So a dead center through my first point, dead center through my second point, dead center through my third, and then my last point. So I drew my rays through my 4 points. It is a factor of 2. This is at 1, 1. What is 1 times 2?
1 times 2 is 1.
2. So I go up to 2, 2. That's my first one. This is at 1 here, and then negative 1. So what's 1 times 2? Is 2. And that's what's negative 1 times 2? Negative 2. Boom. So there's my second one. Then this one is at negative 1, 1. So it's at, there you go, yeah, right there. And then last one, we can use our common sense. So this is our dilated shape. We dilated it by 2, by a factor of 2 about the origin. All right? So let's check that section first. Step 1 of this, dilate WXYZ by a factor of 2. 1, 2, 3, 4. 1, 2, 3, 4. So does that match?
Yeah.
Yes. So that first part is right. And then it says reflect across the y-axis. If I were to reflect this across the y-axis, this point is 2 points away from the y. So it would be over here. And then this point is 2 points away from the y, so it'd flip over here. So would this actually move at all if I reflected it over the y-axis? No. So does this equal this?
Nah.
No, because it didn't move at all. It dilated correctly, but it did not move at all. All right. If I dilate w, x, y, z by a factor of 1/2, so look back at this original. Why do I hear voices? Look back at this original. What does it mean if I dilate by a fraction? What does it mean if I multiply by a fraction? Sorry. If my scale factor is a fraction, what does that mean? It gets smaller. If I make this shape smaller, is it going to equal this? No, so we can cross that off from the jump. I'm waiting for a 0.
I said C.
Now we have the letter C. Dilate w, x, y, z by a factor of 2. Okay, so we already did that. That's our green. We already did that. We dilated it by 2. And then it says translate 6 units up and 4 units to the right. Let's check it. Let's count. 1, 2, 3, 4, 5, 6. So I just moved it. 6 units up. Now let's do 4 units to the right. 1, 2, 3, 4. Is that correct? Yes, C is correct. Let's double check D. Again, scale factor of 1/2. Does that make this bigger or smaller? Smaller. Do we want it smaller? No. So D is incorrect.
Nah.
At least I was close. You said B.
I said C.
All right, so that multiple choice question should be easy peasy for you guys to be able to analyze. All right, now flip it. Last question on the back. All right, this one is not a multiple choice question. You guys need to be able, I'm waiting for a 0 from you guys. You guys are the reason that I'm gonna have to do another feature.
Us too.
Yeah, you guys are nonstop.
That's
Talking. Rectangle ABCD is shown on the coordinate grid below, right here, ABCD. All right, now let's read the instructions that they want from us. Rectangle ABCD undergoes a sequence of transformations that result in ABCD prime. The length of side AB is going to be, AB prime is going to be 3 units, okay? So we know it's getting smaller because this is definitely not 3 units. So it's getting smaller. The coordinates of the vertex B prime are 0, -2. Oh, well, if they give us B prime right now, let's just mark that. So 0, -2, 0, -2. This is B prime. All right, they give us a coordinate for that. Let's just make it. So we can cross that off. The coordinates of vertex B prime, boom, done with that. The coordinates of vertex D prime are -3, -3. All right, cool. So if they find that, let's find over -3 down to -3. This is D prime. Cool, we just did that one. Let's cross it off. Describe the sequence of transformations to triangle ABCD to ABCD prime. Let's double check. They also told us that the length of AB prime is 3 units. If we know that B prime is here and D prime is here, then we know for a fact that the shape is going this way. And we know that AB is 3 units. We can count 3 units this way to find A prime. Because they tell us the length of AB prime is 3 units. They gave us 2 coordinates here, so we plot those. We know that we can move our 3 units, 1, 2, 3, to find our A prime. And if we want to match the rest of the shape, then we just connect the dots. Boom. And then this means that this has to be C prime. Now that we have drawn our shape, they want us to describe a sequence of transformations to rectangle ABCD that would result in ABCD prime. So when we are doing a sequence of transformations, we just have to write it in order. So 1. What would be the first thing we would do to this to get this? What, any step? To get the big one to the small one, what would be the first thing you would do? Yeah. Yeah, exactly. So we have, she counted 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9. We get to 3. We know that we're getting smaller, so it's a fraction. So she dilated by a scale factor of 1/3. So if she dilated by a scale factor of 1/3, we know, so this was our original, like, ray going through our points. She dilated by a scale factor of 1/3. So this is our new shape right here. This is step 1. Step 1. So she dilated down from our original shape. Now that we have our shape here, 2. What is this next step to get this little shape, because this is all we've done so far, to get it down here? What?
Dilated by 3.
No, because we're going down to here. So she already dilated. We already did our dilation. So this is our big one. We dilated it down. See, I made my rays so that I could see. I dilated it down. This is my new shape for step 1. I need to get my new shape down here. So what's the next step? 2.
3 units.
Translate. How many units?
3. Lunch counts.
Oh, yeah, I can do that right now. Let me finish this and then we can go do that. How many down? So 1, 2, 3 down. So we're going to translate 3 down. Now that we're right here, what do I have to translate next? Translate 1 unit left. This is a sequence. This is what they asked for. Sequence of transformation. That is what they want. Describe a sequence of transformations to get our big triangle, rectangle, to our little one. Step 1, she dilated it by 1/3. Step 2, we translated it 3 down. Step 3, we translated it 1 unit to the left. Alrighty.